Hello, welcome to IPDAE's Wednesday webinar. Today, we're going to be looking at MathABILITY simple strategies to build symbolic reasoning. My name is Kate Redman. I'm the CEO and founder of Light and Salt Learning. Super excited to be working with you all in Florida, but I'm over here in another sunny state, Arizona. And I work with struggling students. That's my jam. I've been doing it for 15 years in a lot of different ways as a high school teacher, as an adult education instructor, as a tutor with our partner, Voc Rehab, working with adults with disabilities, and I also create curriculum specially designed for students with learning disabilities and other significant learning challenges. So just remember, oh my goodness. So I see Christine in the chat. Hey, Christine. Sorry, I just got distracted. Christine, long time Facebook friend, huh? But just remember, you all, if you have any questions, you can go ahead and type it in the QA. Actually, you know what? Just type it in chat because I have chat open. And we're going to be using chat on and off through the webinar because I don't like talking to an empty room. I love participation. So yeah, go ahead and do that. Your microphones are muted and you're listening only, but yes, we can participate there in chat. If I do overlook a question because they're coming too fast, though, you could go ahead and drop those in the Q&A so they don't get lost. All right. All right, so we're going to start out with a simple activity, much the same way that I would start out with one of my classes. And this activity has a prize. We are going to be doing a simple little math quiz, 3-word problems. I'll put up the URL in a second, but this is timed, so hold on and listen to the directions first. But I'm going to put up a URL on the screen. You can use the URL or you can scan a QR code with another device. So if you're on your computer now, you could scan with your phone to get to the activity. I'll be showing both up on the screen. So 2 ways to get to the activity. And then there are going to be a couple of questions that I've used to give you just a random version of the quiz. So I just ask you a couple of questions, and that's how I managed to randomize who gets what quiz. But I need you to do something super important. The quiz will show up on your screen after you answer your questions. You get your version. You're going to need to take note of your answers, whether you just jot them down on a piece of paper or something, because you're not going to be able to come back to the quiz when you go to submit your answers. And then you'll move on and record your answers. I will be looking at the answers coming in as we're going and seeing who my winners are. So first 5 with perfect quiz scores are going to win downloads of my new Algebra Essentials GED style practice test that you can use with your students. So you will find those handy. It's like having an extra GED ready test. All right. And hello to everyone. Everyone's saying, hey. Here we go, you guys. Are you ready? Get set. All right, go. Go ahead and visit this URL, bit.ly/MA quiz. And capitalization matters in a slug, guys. So make sure that's a capital M, capital A, capital Q, or you can scan the QR code to get to the activity and answer the quiz questions. All right, I think I'll drop it down in the chat as well, because I want to move on to see you all's answers. So I can let you know if it's time to try again. Mm. Are you all having troubles? Are we getting there? My chat. Come on, chat. There you are. Um, Deb, tell me a little bit of what you mean about it's not working. Are you not getting to the URL, or you can't see the quiz, or you can't answer the questions? Ah, Deb, it's in Spanish. I apologize. That sounds awful. It seems like some of you guys are struggling with this really easy quiz. Application maintenance. You can, wow, we're struggling. We can get to the quiz by going bit.ly/. There we go. We're starting to get some answers. Bit.ly/. Ooh, what did I say? MA, capital A, capital A, capital M, capital A, capital Q quiz. You will have to answer a couple of questions to see the actual math quiz. Uh, oh, some of you guys figured out I accidentally showed the answers on the screen for a second. They're not there anymore. Ron P is our first winner, but Ron, you didn't give me your email address, so can't give you a PDF. If you want to submit again, I'll be happy to do that, or drop your email in the chat. Let's see, who else do we got? Alyssa's a winner. We have Ron. We have Alyssa. Some of you guys are mad at me because you can't get to the quiz. We're having tech issues. And some of you are mad at me because you can't read the quiz. Some of you guys figured out that I'm having tech difficulties and showed the answers to the quiz on there. If you haven't finished filling it out yet, you can go ahead and do that. I do have 5 correct answers, so I am just going to go ahead and move on with this. But I do want to say, how do you guys feel about the fairness of what we were just doing? How fair was that, this activity? I mean, all of you guys had the exact same questions. They were all simple. They were all beginning level style word problems. And oh, somebody's mad at me. They said, funny for you. John, why is it funny for me, but not for you? I'd love to hear what you have to say about that. Every time I transition, it drops my. Okay. People are saying black, they don't understand it. They didn't understand the symbols. You might realize I'm just trying to give you a little bit of empathy. Sometimes we teach and teach and teach the math in our classrooms, and yet students have something else going on. That math is not the issue. There is a processing issue. There's a symbolic issue. There's an understanding, being able to understand the questions in the first place. That's really what's holding our students back. And it's a frustrating feeling. I'm sure some of you saw. Some of you had beautiful versions of that quiz, just nicely formatted, easy to read, and then everyone had varying difficulties, and some of y'all's were just ridiculous, and you'll have to forgive me if they were backwards and upside down. So if you're not already mad at me, you might get a little frustrated, just to let you know, because I do tend to give a lot of information. I'm going to have so much that we talk about today. But good news, you're not going to need all of it to up your game. I recognize that we have people at all different levels of teaching math here. So aim to walk away with 3 to 5 things that you're like, oh, I didn't realize that I could use that in my classroom, rather than feeling like you have to grasp everything. So first, when I talk about symbolic reasoning, what am I even talking about? Why do we need to care about it in the classroom? So this isn't a technical term. It's something that I kind of just started saying. When I say symbolic processing or symbolic reasoning, I'm talking about your students' ability to look at mathematical symbols and get information from them. So I'm not talking about if they can do computations, like they know their basic math. So we're going to do a lot of participation today. And if any of your answers are because they don't know the algorithm, that's not what we're talking about. So that's another class. I'm not talking about remembering the steps, and I'm not talking about skill level, like someone could reason this through, or I'm just purely talking about can they get information from symbols. So again, gaps in symbolic reasoning. If your students struggle with reasoning, I need you to know that's not a diagnosis. You're not going to find that on any, IEP or note from a psychologist. It's certainly not limited to students with disabilities, although it tends to be much more common, like dyscalculia, hard word to say. But that's a common one where students struggle with symbolic processing. They're not life sentences. All the research shows the plasticity of the brain with direct instruction and intensive tutoring. We see these improve. Certainly, they can be bigger struggles for some students than others, but we definitely see improvements. So what is it? I've said a lot about what gaps in symbolic reasoning aren't, but what are they? First of all, it's just a sign that we're going to need some direct instruction in the symbolic language of math. And we're going to be thinking about math today as a symbolic language. So for once, any ESL teachers, anybody who does English and GED is going to have the advantage today because you're going to be able to relate this to a lot of what you do. Gaps in symbolic reasoning are often overlooked or misunderstood. We tend to just keep readdressing the mathematical reasoning part instead of the symbolic processing. And they're super duper common in the adult education classroom. I have been working with other GED teachers and working in the GED classroom for a long time. And I have never been in an adult education classroom that didn't have a handful, at least, of these students. And they are definitely early indicators that a student's going to need some extra support as they tackle algebra. So this is not usually adult education instructors, you guys, if you've seen this little cartoon making its way on the internet, but I always have a couple of old school teachers who say, why do we even bother to teach them algebra? This is too hard for our students. They don't need to do it. So let me just make a quick case for this. Why should we care about the language of math if students can get the right answers without it? And we have some students who are great estimators. We have others who are good at other subjects, so it compensates for the algebra. So why should we even care? First reason is just life is full of mathematical language and symbols. It is, and a lot of the students that we work with, mathematical literacy slows them down, not being fluent, not being literate. Kay had a good point. Algebra is actually quite helpful in one's adult life, but you forget that you're doing algebra. I agree, Kay. Second reason for me is that algebra is all over the GED test. I know they have a breakdown that says it's only 45% algebra, but it's such a lie because you can do almost all the data analysis using algebra skills. You can do almost all the geometry using algebra skills. The slope and line problems are algebra skills. Half the word problems can be done with the formula sheet. I mean, it's algebra. And then this is my biggest reason. College algebra is a gateway to most degrees and certificates. We spend a lot of time focused on how our students need to know basic math for the workplace. And I would argue that algebra is 10 times as important just because it provides such an effective roadblock for our students and their goals. Like, here's the 2/3 of careers that you cannot do because you never learned algebra and all we ever did was focus on basic math. Whereas some of the basic math skills that we spend so much time on are really specific to only certain careers. So that's that's my argument, guys. And then we see that mathematical literacy significantly impacts many areas of mathematical performance. Once those symbols start making sense, you're going to see your students often running in areas that you didn't expect. And then finally, this is my big one. Mastering basic algebra is empowering. It's like this. It's right up there with fractions as this thing where students feel like it's just too hard, it can't be done. And honestly, a lot of times for a lot of students, algebra is easier than fractions. So how empowering, oh, I can do algebra. All right. Oh my gosh, I better start speeding it up, you guys. This my favorite game is to have way more information than I could ever cover. But you guys can always access the slideshow and take a look if we don't finish everything up. But there's a lot of factors that influence symbolic reasoning and how well your students get meaning out of symbols. It can be anything from learning disabilities, ADHD, mental illness, surprisingly, can affect this. Trauma is a huge one, especially educational trauma. And I would make the argument that half your students have some form of educational trauma. Cognitive delays certainly affect the interpretation of symbols. But then there's just inexperience or limited exposure, right? If someone comes up and speaks to you in a language you never heard, they could be saying the simplest, easiest things, and yet you would never know. It would sound like nonsense, and that happens with many of our students. So, since that's just about every student, I am going to encourage you today. We're going to look at how to spot check the mathematical writings of every student, not just your slow students or your struggling students. Every student can use some direct instruction in that kind of symbolic processing, symbolic reasoning. And we are going to learn to look for gaps in fluency. And when I say fluency, I'm just talking like decoding. What do the symbols mean? What do the words mean? Let's put together this vocabulary with these symbols. Syntax or grammar issues. Algebra has a grammar, and this is one where I don't see a lot of you teachers doing this, and it's to your students' detriment. And I haven't been into Florida yet, so maybe you guys are stellar at it. But in some other states I've been in, this is one that gets neglected because if our students had the right answer, who cares about how they did the work? And then finally, this one is a big one with students, especially with dyscalculia, signs of what I call symbol overwhelm. Again, not an official title, but just that whole, they take a look at those symbols and they just freeze up and don't even know what to do. All right, and I'm going to encourage you that the things that we're learning today are useful for every day, every lesson. This is not just your struggling students. Some of you have probably seen this famous little cartoon here. It often gets used when talking about UDL, Universal Design for Learning. But basically, if we put in the tools and the scaffolding that struggling students need, any student can benefit. And so since all students can benefit from focusing on fluency, I would encourage you to direct teach it in general and make that just part of your universal design for learning in your classroom. All right, we're through all the introductions. And look, I'm only 5 minutes over. We're doing great, you guys. So let's look at the first skill, fluency. If you stopped paying attention, it's time to tune back in because it's your turn. Take a look at these student errors. I took them all from student work posted in my Facebook group. By the way, your students and you should be in this Facebook group. That's what Christine's in. We have volunteers and tutors and teachers to help your students. But take a look at these examples of their work, and I want to know, what do you think these student errors have in common? And we're focusing on fluency right now, taking meaning from these symbols. And when you feel like you have something to contribute, go ahead and drop that in the chat. They're all monkeys. I hope you don't mean my students. I get a little pissy when people make fun of my students. I don't think you mean that, but what is going on here with these students and understanding the symbols? I love this. I see different ways to show operations like division. I see that too. There's definitely different ways to show operations, but these students are all making common errors here that have to do with understanding symbols. Oh, so okay. Alyssa says when they are all monkeys. So Alyssa's saying not that she's dissing our students, but they're copying what the work looked like without understanding the representations, concepts themselves. I love this, Darcy. Yes, yes, definitely one of the things I was looking for. They do not understand what the symbols and terms are asking of them. For example, the negative versus the minus. Not sure when to interpret that same symbol, right? We use the same symbol for two different concepts. When do we interpret it as a negative? When do we interpret it as a minus? We have a student who can't decode, or not even decode because they're decoding it, but they can't read that word in context. Um, oh, I love that. So Christopher Sawyer says the problem with the 1 minus -3 should be a plus. He's looking at the bottom left, but take a look at that. Look at what that student did. They didn't minus or plus. What did they do? They misinterpreted a symbol and did the wrong operation. What operation did they perform? Bingo, they multiplied. Guys, what symbol did they misinterpret? Deciding to multiply. Parentheses. Bingo. I got a whole lot of teachers out there who teach their students that parentheses mean multiply. They obeyed you. All right, let's keep going on. I love this. Great conversation. All right, I have some more here we can look at. And if you can't find it in common and you just want to point out something, that's great. But again, I'm going to encourage you, what misinterpretation of symbols is going on here? That's what we're specifically looking at. So what aspect of fluency might all these students be struggling with? Alyssa says, ouch. I know. I know. Mm. Aparna says, which, I hope I pronounced your name right, but which side is greater and which side is smaller? There's definitely some issues with that going on. With especially 21, we see that link. They probably have that, oh, you just draw the arrow in the direction of the symbol. I've heard that from students a lot. And yet, even though that's a trick we teach, just draw the arrow in the direction of the symbols. We can see that's not going to work on 21, at least not the way their answer is currently given. Okay, Alyssa says number one, we have a definition of a solution. I love that. Alyssa, yeah, we don't understand the definition of a solution. So I think it's interesting because they kind of disrespected the equal sign in that first one. When you say definition of a solution, yeah, we don't have a solution at all. All of a sudden, we've randomly transferred to some kind of an expression. So yeah, when I look at these three students' work, maybe I'm not giving you guys enough time to think about it, but I see all these issues with not understanding that these mathematical statements are two-sided. There's something happening on the left and the right-hand side of either this equal sign or this inequality sign. And not understanding that is leading to a lot of mix-ups here between simplifying and solving. So gorgeous. Alexander, I agree with you that the letter P needs to be on the left. However, if that's all you teach, the letter has to be on the left in order for the symbol to be in the right direction without this understanding. Really important that they understand what those symbols mean, right? All right. Alyssa says, she says, don't disrespect my equal sign. Alyssa, you got that from me, didn't you? I get real touchy when you disrespect the equal sign. I have a new PD that I'm planning about equality for equality. It's still developing, guys. Okay, next one. More signs of gaps in fluency you all should look out for. One of them is naming symbols instead of reading algebraic expressions. So if they just come up on the exponent 2 and they say 2, or they come up on a parentheses and they say parentheses instead of fluently speaking, that's a sign that we have a gap in fluency. So a student might read this as 4 parentheses x minus 3 parentheses. And they've literally told me the name of each symbol, but they have not told me the meaning of this expression in this case. So somebody be brave. There's more than one way to do it. What's a way that you would expect your students to be able to read this? Sterling says x minus 3 is a quantity. I love it. Anna, I kind of agree with you, but if you say 4 times x minus 3, there's no way to distinguish if you mean 4 times x minus 3 or 4 times x minus 3. Mathematicians prize clarity. How could you tweak your statement to make it clearer? Christopher Sawyer's like, I'll just flip the order. I don't know, because I definitely could do x minus 3 times 4. I love this. Dustine says 4 times the difference of x and 3. And Dustine, I would almost agree with you, except for if you use the word difference, difference is always positive. We can't guarantee that x is a number bigger than 3, and so you would have to use absolute value bars. So close, but not quite there yet. Sterling, I absolutely agree with you that the distributive property would be used if we simplified this, but how could I just read this statement? I love it, Anna. You are the first person who said it clear enough that no mistakes could be made. 4 times the quantity of x minus 3. And certainly your students can say close quantity. Oh, I love that. Authorine said an unknown number minus 3 is then multiplied by 4. Glorious. A lot of great ideas. I love it. Thank you, guys. Next one. Oh, come on, Kate. I have tech issues. There we go. How would we read this? Any thoughts? I have a lot of students who say minus 5z3, by the way. I love it. Negative 5 times z cubed. Gorgeous. Nice job, Sterling. I'm going to go on. Okay. Students might also have trouble transcribing mathematical statements. I know you know this. Your students are like, the hardest thing to do is writing algebraic expressions, equations, and inequalities. And then, of course, that hesitancy reading and writing expressions, equations, and inequalities. And another thing that you might not think of is repeatedly starting over instead of correcting their work. If they can't go back and read the symbols, they can't just look for where they went wrong. They have to restart every time. So that particular one we're going to talk about later. It can be a sign of many different things, but it can indicate that this is going on. So let's talk about scaffolding for that issue of fluency, of just not understanding the symbols and their meanings, especially in context. So the first thing is that I would encourage you to build to fluency. Instruction doesn't stop at learning symbols. Just like when you're teaching reading, you don't just stop at teaching your students the name of the letters in the alphabet. Imagine if reading instruction stopped there. You would definitely have students who just never learned to read. And that's what's happening in our algebra classrooms. And then remember, please, that fluency builds. Yes, we're going to teach them the meaning of the symbols, but then we have to look at those symbols in context, in the context of expressions to see what they mean. Parentheses are a great example of that. Parentheses are the most multi-use tools in mathematics that I can think of. Please stop telling your students they mean multiply. They simply do not. And we'll talk a little bit more about that later. And then when you start putting expressions together, like we do with equations or inequalities, that's when we start getting complete mathematical statements. And then finally, we use complete mathematical statements, both expressions and those um, more complex equations and inequalities to form logical arguments. And your students need to be, we need to have direct instruction at each step of this as your students build to fluency. I am going to encourage you to not just direct teach the names of the symbols, but the meaning of the symbols. So please, 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 maybe some of you have seen this video from me. Could you please stop calling inequality symbols alligators or arrows, or telling your students they point to the bigger number? Because now all of a sudden we have a fluency issue when I need them to read algebraic inequalities. That worked when we were just comparing a couple of numbers, but it doesn't work for fluency. We need to graduate. So just real quick, how would you say something like this? And you don't have to overcomplicate it. Just simply read it. Beautiful. And it's greater than or equal to -11. Glorious. And then here, my big pet peeve. If I didn't get mad at you for the equal sign, I'll get all fussy about the parentheses. So parentheses are very, very multi-use. Your students need to be trained in using context for what they mean. We cannot teach our students that parentheses mean multiply. They actually don't. There's never a time when parentheses mean multiply. If anybody wants to argue with me, they can email me and I'll show you videos. But yes, I would absolutely read this as 5 times -35, but it's not actually the parentheses that are telling us to multiply here. It is proximity. If anybody has been seen enough of my videos, you know I will harp on this. Proximity, when two things are shoved together, means multiply. Now, why would we also use parentheses? That's when we can't tell that two things are next to each other without them. So if I left them off here, you would think I was talking about 5 minus 35. If I wanted to do 5 times regular 35 and I just shoved them together, you would think I was talking about the number 535. So the parentheses there are used to give you a visual differentiation between the two numbers. But the thing that's making them multiply is the proximity, the closeness. Exactly. Next to means multiply. Great, Sterling. I love it. So then this guy, we already talked about one like this, so I won't stay on it. But how would I have my student read something like this? Again, I wouldn't say 5 times x minus 35, because then I'm not giving you the signal here that there's not only multiplication going on here, these parentheses are being used to group. We have a grouping. And so I love that phrase, the quantity. I use it often. 5 times the quantity of x minus 35 would be a great way to go. Alyssa, isn't it great that we teach adults? Alyssa says it's like rabbits. They touch a lot. They also multiply a lot. Bingo. All right. There's not multiplication in this expression. Now, I know some of you are like, but we could rewrite it as multiplication. Yes, but it's not currently multiplication, right? So what's going on here? What are my parentheses being used for here? Again, we see that it is indicating exactly what is getting squared, that we have a grouping getting squared. I love that. Yes, I could read it as the quantity of x minus 5 squared. Or you could say square the quantity of x minus 5. Raise the quantity of x minus 5 to the second power. Beautiful. And then this one, again, we saw that student earlier who looked at this as a multiplication, and this indeed says 5 minus -35. And once again, those parentheses are simply just to give us a visual separation between the minus and the negative to avoid confusion. That's their only purpose. How about this one? Because I got a bunch of your students who say, not your students, sorry, but I have a bunch of students who come to me saying this means f times 5 is 35, so therefore f is 7. So we'll just, this is on the GED. They do need to know what parentheses mean in this context, and it's all over college algebra. So could somebody read this? Yes, Stacy, it means function of 5, but can I get like a complete sentence here? This is definitely a complete mathematical sentence with that. I'm going to slip a little more verbiage in there. You could say that there is a function in which an input of 5 gives an output of 35. You don't have to overcomplicate it though. It would be sufficient for your students just to be able to say f of 5 equals 35, or the function value at 5 is 35. But f of 5 equals 35 is fine. I just don't want them saying f times 5. All right. And then this one, right? Parentheses don't mean multiply at all. In fact, I had to add some wording here, lies on the line, because without that context, there was still parentheses 5 comma 7 actually has two meanings in math. But in this context, what am I talking about if I use parentheses here? What is being indicated? Graphing, yes. What aspect of graphing? Specifically, what piece or part? Bingo, a coordinate pair or a point. Your student should look at that and read in context, the point 5, 7 lies on the line. Can they verbalize that? Beautiful. So I would encourage you that reading and writing is a lifestyle, not a day's lesson plan. I've never met a book yet that wasn't written by me anyway, that didn't teach writing expressions like one class and writing equations like one class and writing inequalities like one class. And I just imagine if you did that in Spanish class, like you never ever spoke until towards the end of the semester and you did it for one day. It just doesn't even make sense. So I would encourage you when you are working problems, as we tend to call them on the board with your students, you read them aloud before you ever get started on the math. They need to hear what it says, or else they're just trying to memorize what steps go with symbols without any meaning, and it's horrid. Okay, and students should do the same when they're practicing. They should be saying things to themselves. And I know that sounds a little weird, but we need to have students who start speaking the language. And then, so one way to do it is practice transcribing both ways. You can do it with a student, but you can also have them pair up and partner up, that they're looking at an expression, transcribing it or saying it aloud and getting their partner to transcribe it. And if the partner is not writing what they think they're writing, then they can get this feedback, this back and forth, kind of like we just did. And then, of course, give feedback, give feedback. I think it's really important. Students are so caught up in this like right, wrong thing with math that they don't get with other subjects. So just this idea of, I love the way you did this or said this, but I am not sure about your meaning here. Mathematicians love clarity. Help me out with some clarity. Let's use some additional wording here to clarify what you mean. We would do that in an English class and it wouldn't be a big deal. All right. Another thing for scaffolding fluency is we need to use our key terms frequently and accurately. I love adult education teachers. You guys are the best. You love your students. You try to simplify everything for them so that they will be successful. But a lot of times we actually divorce key terms like the mathematical terms from their meaning. And then our students, they might know what to do, but they don't know what's going on. It's this weird kind of like teaching a native Spanish speaker, only teaching them Spanglish. Like, we're not going to teach you all of it, just enough for you to get by. Avoid ambiguity. Don't use terms that don't have specific meanings, or at least not without pairing them with their specific meanings. So a great example is problem. I hear teachers call math examples problems all the time. Now, if you don't know what it is, or you have a mix of them, obviously I do have to say problem. But if you know specifically what you're looking at, are we looking at an equation? Are we looking at an expression? Are we looking at an inequality? Call it by its name. And then same thing with work or do. Work the problem, do the problem. Do you want them to solve? Do you want them to simplify? Do you want them to factor? Do you know the difference? Because I've had a lot of teachers think the word solve just means find the answer, and it doesn't. And that's another one of my big pet peeves. All right. Solve is specifically to find a value of the variable that makes the equation true. And so don't tell them to solve when it says 5 plus 3. They're not solving. They're simplifying. If they do 5 plus 3, they tell you 8, they just simplified. I know we use memory phrases all the time, simple things that make sense to our students. There's fine. There's nothing wrong with memory phrases, but make sure you pair them with the academic terminology so they do learn to speak math. So here's a great example. I'll just sit back because you guys are all saying this to your students all the time. What the heck does keep, change, flip mean? What is the academic terminology for what your students are doing? Bet you know what I'm talking about because y'all are all teaching it. I met a teacher who had a dance, a keep, change, flip dance. I know there's some of you guys who are teaching keep, change, flip. What are we talking about when we say it? Dividing fractions, dividing fractions. Wonderful. So we're in the land of dividing fractions, but what am I telling them to do when I keep, change, flip? What is that process referred to? Yeah, Alyssa's telling me why it works, absolutely. But mathematically, what do we call it? What's the academic terminology for keep, change, flip? You can say keep, change, flip, but you just better say the math term for it as well. Reciprocal. There we go. Bingo. We're multiplying by the reciprocal. Instead of dividing by the fraction, we're multiplying by its reciprocal. And I love that Alyssa wants to explain why that works. That idea of two opposites canceling each other out. Certainly, your students can benefit from that as well. But all I'm saying is don't forget to point out that dividing by a fraction is equivalent to multiplying by its reciprocal. Some of you guys just point that out once, and then for the rest of the year, you just say keep, change, flip, and we never link the meaning to that because there's so much going on. Okay, next one, cross multiply. Cross multiply, that's kind of like a process for doing a problem, but what are they actually doing when they cross multiply? It's not cross reducing. No. Cross cancel. Ooh, Christopher, that's an interesting thing. And you can use your own term for it, cross cancel, but what is it? What mathematic principle are we doing when we do that? Multiply the numerators and denominators. Okay. I like setting cross products equal because that's the term they're going to see later in math. The idea is cross products are equivalent. Absolutely. And you can prove why. Some of you are telling me ways to prove why that works. That's great. Alexander, be real careful with the word simplifying. Simplifying is a huge, broad term in math. That's one of those ideas about avoiding ambiguity. Simplify literally means obey the operation. So I would not refer necessarily to this as simplifying. I call it Gemma, another one of my little pet peeves. I hate PEMDAS, but if you say PEMDAS, that's fine. I mean, it's not fine. We have to sort out our differences. But what am I referring to, whether I say Gemma or I say PEMDAS? That's just a mnemonic. It's not academic terminology. What is it? Thank you. The order of operations. And by the way, guys, if you tell all your students that the order of operations starts with parentheses, I'm going to call you a big fat liar because parentheses is not an operation. I'm saying order of operations. If parentheses is not an operation, that can't be the first thing to do. All right. Next one, FOIL. FOIL is not a mathematical term or process. Again, it's something to help you remember a process, but what am I referring to? What are we doing when I hear teachers use it as a verb, foiling. Oh, Kay says, so what is the term for doing all the stuff in the parentheses? Kay, I usually say prioritize the operations that are inside of groupings. Math is an inside to outside language. So we're going to start with the insides of groupings. And yes, we see parentheses and groups in parentheses, but the idea there is inside to outside. If Google can be a verb, why can't FOIL? I love it. It's Aparna, it's definitely related to distribution. We use that term FOIL usually to help them keep track of a specific distribution. Which one? There we go, Sterling, multiplying binomials. Multiplying binomials. So FOIL can help you remember how to multiply binomials, but what are our students doing? They're not foiling, they are multiplying binomials. So pair the language. I'm not saying get rid of simple terms, just pair them. How about that one? My favorite. Get the letter alone. I use it all the time. If you've watched my, especially my older videos, the longer I do this, the smarter I get. So I've started always pairing this with what it means. What am I saying? Thank you, Anna. Isolate the variable. Isolate the variable where? Do I just write X in the corner of my paper? I love it. Sterling says isolate the variable to find out who he is. I do that too, Sterling. I'm all about personifying my variables. Yeah, so isolating the variable or solving for the variable. Yeah, isolate the variable on one side of your expression or inequality. I mean, one side of your equation or inequality. Gorgeous. Oh, here's another one, you guys. You guys, I love it. I get you just tell your students all the time, remember, move the decimal 2 places to the left. The heck, what are they doing when they move the decimal 2 places to the left? Bingo, Sterling. They are dividing by 100. We're not turning a percent into a decimal by just moving 2 places, some mysterious movement. We are dividing by 100. Gorgeous. Oh my goodness, how far? Oh, you guys, I'm about halfway through where I'm supposed to be. I have so much to talk about. We will definitely post this up. Okay. Let's talk syntax. This is one of those ones. If you're an English grammar nerd, you know how hard it is to get people into your to get super psyched about what you're doing. It's similarly hard for me to get instructors and students psyched about syntax or the grammar of mathematical statements. However, I will just say this to you. I have never met more of a game changer with students with dyscalculia than this. If you can direct teach them the grammar, the syntax, it is revolutionary to their understanding of algebra. So it is well worth your time, even though it might feel a little nitpicky. All right, so this student is technically correct. A lot of you guys would not correct this, would not have your student change anything, but there is a syntax issue, something that's not, it's not normally written this way. So anybody see the syntax issue that this student is making? What grammar problem do we have going on here? Beautiful. The denominator should be 6K. If we want to say that 6 and K are multiplying mathematically, the correct syntax that we use is to shove the two things together, right? Proximity means multiplication with the coefficient, the number first, and the variable, the letter second. Gorgeous. Next one, we have some similarities here, and these guys have some similar struggles. So what syntax could we clarify for these students? This one looks hard. Do I even remember my right answer? Right answer. Oh, I see it. Oh, it took me a minute and I wrote the problem, y'all. I'll give you a second. Bingo. Marcia says it's not in a solution format. Absolutely. If I start with an equation, every line that follows should be an equation. If I start with an expression, every line that follows should be an expression. If I start with an inequality, same thing. And so we see these students just divorcing what they think of as the answer from this mathematical argument. They're just writing the number without knowing what this number represents. So yeah, I would expect to see n equals 4.6 or X equals 22, so on and so forth. And I know you guys are like, not that big of a deal. I promise you, one of those things that can be really groundbreaking for students with, to understand that idea of if I'm starting with an equation, then I'm looking for a solution, not a simplified expression. and more signs of developing syntax and structure to watch for. So I just use the term developing instead of struggling because, you know, you're on your journey to language. You might have some fluency, but not you're not totally there yet. So this is a big one, presence of computations, that scratch work in your formal algebraic writing. If you see your students like doing the scratch work for 16 times 3 right in the middle of your algebraic equation, we don't want to see that. There's another one. If any of you watch my videos, you know I'm such a brat. I tell my students, I don't care how you figure out what 16 times 3 is. I don't care if you use your fingers, your scratch work, you call your mama. I really don't. I just want to see your formal algebraic writing. Another big one is that they confuse expressions with equations or inequalities. They can't tell the difference visually. They don't know when to do what. A lot of you teachers don't know the difference between an expression and an equation. So we will look at that later if I get to it. um, Confuses simplifying with solving. I know you've seen like a student who's supposed to be combining like terms who all of a sudden subtracts 7x twice from this expression. You're like, what is going on? But that's what's going on. They see an x and they think they can work opposite. And they don't know when it's time to simplify and when it's time to solve. All right. Whew. Scaffolding syntax. So how can we help our students to better understand what they're looking at and to develop these syntax skills for themselves? So the first thing, I know, not that much fun, direct teach grammar. Now, again, this is one of those times where I'm about to shoot a ton of info at you. If you take away one important one that comes up in your classroom a lot, I'm going to call that a win, okay? Because I know some of you guys are like old hands at math, that you could be teaching me a thing or two. And some of you guys, a lot of you probably, that's how it is in adult ed, are like, I am not a math teacher, but I have to. All right. So first thing is that we combine our symbols to write expressions. We already talked about this one. I won't go into it with a lot of detail, but how do we combine our symbols? We use that proximity for multiplication with the coefficients first, right? And we put things together, proximity, when we're multiplying with the coefficients, the numbers out front. We work inside to outside. That's a weird thing to think about, but math is an inside to outside language. It's pretty much never left to right. It's inside to outside and then top to bottom. Our higher order operations are nested within lower order operations. I'll show you what I mean. So my higher order operations, like think of it as what we learned later. You can see that when you look at this expression here, 5x squared plus 7x cubed. First of all, we have the highest order operation here is a power, an exponent, right? An exponent means repeated multiplication. And we see that that x squared expression or x cubed expression is nested within a simpler operation, multiplication. So that x cubed is nested inside with 7x cubed. And I know it's a little weird to think about inside, but that meaning that it's the x cubed, that whole x cubed that's being multiplied by 7, not just the x. And then same thing here. And then we can see again that that multiplication then is nested within our addition. That's our terms, right? What's adding? This whole multiplication expression is adding with this whole multiplication expression. So we see this nesting feature to mathematics. I'll show my email at the end if you guys want to ask more questions about that. I realize that's a little academic there. And then if we need to manipulate that nesting, change what's nesting, then that's when groupings are pulled out. And so, of course, if I wanted that 5, not just to multiply by the x squared, but to trump, get that addition into what's being multiplied, then of course I could use those parentheses to group. Oh, I don't know why I didn't put others. That's okay. But there's other ways to group as well, right? Anytime you're inside of something. All right. Next, direct teach syntax or grammar. We have 5 minutes left. I'm going to see, because since I get super technical with the grammar, Oh, yeah, no, I do want this. Expressions versus equations. Okay, let's talk about this. This is a huge one, because students don't know the difference and how expressions and equations are built. So this is a good use of our time. Okay, so one of the grammar things you should direct teach is how we combine expressions to make relational statements. And like I was saying before, a lot of teachers don't even know the difference between simplifying and solving, or expressions and equations. And that's this big, huge, crucial difference for students. Those are the two different playgrounds of algebra. We're either simplifying or solving about 99% of the time. And they have different opposite processes, in fact. And so if you don't understand when to use what, you're just memorizing things, you're using algorithms whenever. It's just, you get your students doing all kinds of nonsense. Okay, so super important. So first thing, let's start with expressions. Expressions are just values, and they behave like the subject of a sentence. So think of like your noun. So they can be simple, a specific noun like 7 is an expression. Yes, it's a number, but it's also an expression. Or X, yes, it's a variable, but it's also an expression. It's like a noun, how just a single noun can be the subject of a sentence. But more complex expressions, they're still values, even if they're unsimplified. Like 2x squared plus 1, I haven't done the math. It isn't any simpler, and it can't get any simpler right now since I don't know what x is, but it still is some value. And so that is still like the subject of a sentence, that expression, kind of like you could say the fat black cat as the subject of your sentence. Thank you, Tammy. I'm running out of time, you guys. We're going to wrap up with this one. And then we form complete math sentences when we add a verb. Equal signs, inequality symbols, approximately equal to, not equal to, all of those types of symbols, those are the verbs. And so once we see a relationship between at least two expressions, now that's when we have a complete mathematical sentence, or making a complete sentence. So in this case, x is approximately equal to 3.14, or y is equal to 4x minus 2. 7 is less than n, which is less than or equal to 54. We can see 3 expressions combined here with a couple of verbs. It's a more complex sentence, but it's that same idea. We're putting together expressions and relationships between them to form complete sentences. And it's super important that your students can visually identify when they're just looking at an expression versus an equation or an inequality. Yeah, they can take other forms. They don't need this for the GED, but I did just want to point out that it's not only expressions that we see in relationship in other areas of math. All right, what do we have? 3 minutes. Yeah, we will say this. Okay, here's my other one, guys. Math is inside to outside, but it's also top to bottom. Top to bottom. This is a weird thing, but I'm going to just beg you, if you have a student who does 2 times 5, say they're just simplifying a really simple order of operations expression, and they go, okay, 2 times 5 is 10 plus 7. And then they just randomly jump up here to the top to give you the answer. Do not do this. This is such an issue if you jump across the equal sign when simplifying, for students then to transfer into the world of solving equations. Please make sure your students always simplify down. They should move down when simplifying. I used to say mathematicians go down, but then my students took it real personally, a lot of weird comments. And so we stopped with saying that. But yes, they need to simplify down so they can understand the difference. All right, you guys, I got through about half the presentation. Lovely. But I had a really fun time with you guys today. Super great. You guys are so good at participating. I appreciate that. I hate it when I just sit there staring at the chat box all alone. And it was, yeah, wonderful. So let me get out of here. Oh, we have the poll. I got to get to the poll. Okay, so you should have a poll there to fill out to say how the training went. Go ahead and fill that guy out. I can't get to my last slide. There we go. Ha, fill out your poll. And while you're filling out your poll, I have an announcement. I will remember my instructions. You all are invited to the next webinar, which is a Tech Tuesday webinar on February 25th. They're doing an intro to Tableau, which will give you an alternative solution for data analysis. All right, you guys, I appreciate you.